This is Euclid Book 10, proposition number 72. And it says, if two medial areas incommensurable with one another be added together, the remaining two irrational straight lines arise, namely either a second bimedial or a side of the sum of two medial areas. Okay. For let two medial areas, A, B, and C, D, incommensurable with one another, be added together. This is one area, this is the other one. They are incommensurable with each other. Okay, and we're going to add them together. I say that the side of the area AD, which is this line right across here, is either a second bimedial or a side of the sum of two medial areas. For AB is either greater or less than CD. So this is either greater than CD or it's going to be less than CD. First, if it is so chance, let AB be greater than CD. Now, right at this point, we're going to say that this is bigger than that. Let the rational straight line EF be set out. There's rational straight line EF. And to EF, let there be a rectangle. Okay, we're going to apply a rectangle called EG. That's this rectangle right here. It's going to be EHGF. That's what's going to happen. Now, EG is going to have the same area as AB. This area and this area are exactly the same. Okay? And it produces EH as the breadth. There's EH. And the rectangle HI, now we're going to make HI right here. Okay, it's going to be HKIG. This is HI right here. It's going to have the same area as CD, which is this one right here. And then we're going to produce HK as the breadth. Now, since each of the areas AB and CD are medial, since these two areas are medial, therefore each of the areas EG and HI are also medial. These are two medial areas. And they are applied to the rational straight line EF. They are both applied to this rational straight line. How do we know this? Because HG is the same length as EF. Okay, and we already know that EH is the breadth of this and HK is the breadth of that. Therefore, each of the straight lines EH and HK, these two straight lines here, this one here and this one here, they're both rational and incommensurable in length with EF. Okay, so this line is not commensurable with this, and neither is this. This is by Euclid Book 10, proposition number 22. And since AB is incommensurable with CD, okay, since this is incommensurable with this, and AB is equal to EG, since this is equal to this, and CD is equal to HI, we know this is equal to that, therefore EG is also incommensurable with HI. This is incommensurable with that. But as EG is to HI, as this is to this, so is EH to HK. So is this length to this length. This is by Euclid Book 6, proposition number 1. Therefore, EH is incommensurable in length with HK. This is incommensurable with this. This is by Euclid Book 10, proposition number 11. Therefore, EH and HK are rational straight lines commensurable in square only. So these two lines are only commensurable in square. Therefore, EK is a binomial. This is binomial here. This is by Euclid Book 10, proposition number 36. But the square on EH. Now, how are we getting the square on EH and how are we getting the square on HK? Well, here's how that one works. You have the line EH right here. We're going to make a square out of it. And all four sides of the square are going to be the length of EH. Same thing with HK. All four sides of this square are going to be the length of HK. Okay? So, this is greater than this, either by the square on a straight line commensurable with EH, or by the square on a straight line incommensurable with EH. First, let the square on it be greater than the square on a straight line commensurable in length with itself. Now, neither of the straight lines EH and HK is commensurable in length with the rational straight line EF set out. So this line is not commensurable with this. This line is not commensurable with this. Therefore, EK is a third binomial. This is a third binomial here. This is by Euclid Book 10. Second set of definitions, number 3. But EF is rational. Okay? So this is rational across here. And if an area be contained by a rational straight line on a third binomial, the side of the area is a second bimedial, which is by Euclid Book 10, proposition number 56. Therefore, the side of EI, this is this side right across here, that is AD, that's this right here, is a second bimedial. This is a second bimedial, and so is this. Next, now we're going to change things up a little bit. Let the square on EH be greater than the square on HK, so this is still going to be greater than this, but now the reason is by the square on a straight line incommensurable in length with EH. Now each of the straight lines EH and HK is incommensurable with EF. And we now know this. So this is incommensurable with this is incommensurable with that. Therefore, EK is a sixth binomial. Now we're going to say that EK is a sixth binomial. And this again is by Euclid Book 10, second set of definitions, this time number 6. But if an area be contained by a rational straight line and the sixth binomial, the side of the area is the side of the sum of two medial areas. Okay, so now we're going to say that this side right here is the side of the sum of two medial areas, which of course is by Euclid Book 10, proposition number 59. So if the side of the area AD is also the side of the sum of two medial areas. So now we can say that this is the side of the sum of two medial areas. And that is the whole proof. Alright, I will tell you more in a future video. Stay tuned.